Wonderful. Let me introduce myself very briefly. My name is Warschewske. As told already, I'm a senior consultant and COO of Tecurat. We are in the business of consultancy for medtech developers in the field of digitalization, process optimization, and also of development of medical devices, because most of our people are lifeblood developers coming from the medical device industry. I have a track record about 25 years in development, focus on image-guided surgery, robotics, neuromodulation, and information management systems in the medical field. And I think my presentation today will go seamless over to my previous speakers. So I will talk about information complexity, about risk management, and also about traceability, and a little bit about FDA. But my focus here is a little bit on digitalization. So I want to talk about how this information can be handled and managed with the help of databases. So the journey I would like to talk about today starts with a tiny miss approach. It was an FDA audit in the mid of 2000. So we had our first design control implemented in a database. We were very proud on this because it was at this time a very innovative step. And we were highly self-convinced that we had done a brilliant job so that we have a good data base where we can discuss our issues and we have a good traceability of all of this. And then, unfortunately, the auditor was not very well in the field of our technology, so he had problems to understand our product, and we have had a little bit problems to talk with him. So it was a little bit confusing. So he was mismatching the physics a little bit, and we were always trying to catch it up. But on the other side, he was asking and auditing in a totally different way. So he was asking questions. So if A, then B, and if not B, then it was an error, a mistake. He was capable on this way to find gaps, to find inconsistencies. And honestly, we all in this audit start sweating at this moment. So we were a little bit confused, and it was a little bit a wake-up call for us. But after this audit, I've got a lot to think about. So I was shocked, I agree, but I also was amazed about his method. So he was crunching the complexity better than we did with our database. So he was able to figure out with the data logic, he was able to figure out what's going on without deeper understanding of the technology. And I thought that this is something what we can do with the help of the technology, with the help of a database, not only on samples like the auditor, so that we can do this on the whole data set we have. And this was a starting point of what I would like to show you today on the example of risk management. That means I want to show how we can implement risk management with traceability, change management elegantly with the help of a database. But before we go into these details, I would just jump one step back just to explain the situation a little bit and come closer to what I want to show you. So usually when we have companies where we are reviewing risk management and design control, the usual approach is that we find a table with a risk assessment, and we find a table or a database with design control where we have the requirements and the test cases as a definition of done. So Doesn't matter if this is an Excel table or Word or a database, but the principle I would like to show here are quite similar in a lot of cases we have seen. So that's why I want to go in here. So having a closer look on the risk management, on the risk assessment, what usually happened is that everybody had kind of list of categories, and then selected team of people is in charge to decide based on these categories what might go wrong with this product if this is released to the market, what happens with the operator, what happens with the user, and so on. Having a closer look on this procedure now is that, okay, going from this category, people saying, okay, what might go wrong? What is a hazardous situation? Some people saying, okay, what is the outbound misbehave of the device, which is causing some harm? Yeah, and then there is a more or less accurate trace down of a failure tree until we capture the reason for this outbound misbehave, what is more or less the hazard of this risk. That means this is considered then as a risk. We have all this hazardous situation. We have a chain of event. In between, we have the harm, what we can use. So this is always then part of the risk assessment. And because it's very comfortable working in this table, mostly the risk mitigation, if required and if possible, is also added to this table. So at the end, we're ending up with a kind of scheme that we say, okay, we have our risk assessment file with a risk, the harm, and the risk mitigation in a data structure, very similar like this here. And we have our design specification file where we have mostly 3 design levels with requirements, with test cases, and might be an upward traceability regarding the coverage of the requirements. But here, without going in too much details, we have already 2 very crucial issues we have to deal with, and these are 2 questions. First of all, how is the risk coverage? So if I go down and just having on my fingertip, on my gut feeling, a decision what might go wrong, okay, I have the categories, but how deep I am in these categories, what is the coverage, what is always strongly depends on the technical and medical knowledge of the people doing this. And the second point, what is highly critical having to these disconnected systems, is change management. What happened if I change my device in an iteration? Yeah, I have always this kind of domino effect. I'm changing requirements, the requirements are depending from each other, risks will change, and so on. Having an initial device designed using these both tables seems to be doable, but I think it becomes more and more a nightmare if the design changes and the people involved are changing. So there's always a lack in information transfer. And that's why we have tried to go away from data containers to more logical networks in a database structure. And this I would explain here on this sample. First of all, we have to get rid of prosa and texts, floating text, how we are describing our work items. So either it is risk or it is a requirement. So the first of all, what we need is a well-defined data structure of the work items so that we have a lot of attributes we can use for interface description, risk assessment, usability, and the definition of a requirement by its own. And as I will show later, there are a lot of attributes which are not obvious in the first approach. But this is a very high requirement at the very beginning to create a useful and feasible data structure. So then we start with what I have told so far, that we say, okay, we have our requirement and we have our test case as it is done. Now, the next point comes. So what we are doing here is not a top-down approach from a category down to the source of risks. What we are doing is that we are choosing each requirement. So each requirement in each single level, we have the question, is there a risk if the specification will be fulfilled? Or is there a risk if the specification will not be fulfilled? So using this method will at least warranty that we have a coverage, because whenever we have a requirement, we do this. This is a high systemic approach to cover whatever needs to be considered. And the next step is, if we coming to the conclusion that there is a risk, then we claim this requirement as a source of risk. So that means later on, we need at least one risk assigned to the source of risk, which will then describe the hazardous situation, the sequence of event, harm, as I told you. Also here, it's not only the four attributes, there are much more attributes you can use for risk management. And if we have this, then we can come to the discussion that we say, okay, can we have a mitigation for this risk? And if we come to the conclusion that we can come to this to a mitigation, we add this mitigation. And what is this mitigation? A mitigation of a risk is nothing else than another requirement. So that means we say, okay, there is a requirement, what we are using, pointing to the risk, what it is mitigating. And so we have created traceability. That means later on, if we have design changes, we see, okay, if we want to change a requirement, what is a mitigation? We have to be careful to see what is this doing with the risk. If after changes, we will still have a mitigation of the risk. Another point, what is very important, is the testing. So each requirement will be tested of implementation. So definition of done will be checked. If we have a requirement of the type of mitigation, we have to add the test of effectiveness. So we can automatically trace if we have test cases, we have different kinds of test cases. In this case, we have effectiveness and implementation. So this means because we are checking every requirement if it is source of a risk, of course, we're also checking requirements which are mitigation. So we are fulfilling two very basic requirements of the 4971 that we say each mitigation is checked for further risk and each mitigation is checked on effectiveness. So we have this all in the traceability. And as you see here, the logic is already inside. It's very easy to say that we can create logical change. If there is a yes, we have to check not only for implementation, we have also check for effectiveness. And you can enhance this. So you can also include usability. That means if you enhance your requirement and say, okay, is this kind of requirement a requirement where user interaction will appear? And you can answer this question with yes, then you have finally, and it is source of a risk, then you have a primary operating function in regards of usability 62366. Yeah, that means, okay, you have this complete bundle here, and then you have something in addition. If this is a primary operating function, you not only need to check the implementation, you also have to check usability. That means you need a usability test case depending on the level of this requirement. Either this is test what you can do in-house, or you have to use the users, medical people in the top level. Yeah, but at least you have the traceability in. So this shows the complete the complete design here. I have folded it a little bit, and you see we do the risk assessment in each level of the design. Because what we are doing here, if we are doing it level-wise, we're changing the point of view or the altitude of flight, I like to say. Here, we are checking the device as in whole, so from the outside. Here, we're having a focus on the modules of the device, and here, we're having the focus on the concrete design of all the nits and bits what we have in our device. And finally, if we are finding a risk in a certain level, and we having a requirement what is according to the level in this abstract way, based on the traceability of the sub-levels, we have always ensured that risk we will find in level 1 and in level 2, we will transfer into a dedicated design. So that means what we are doing here, it's now that we could have button-up approach compared to a top-down approach, but we can also have a top-down approach. So what is very seldom done in databases of design control, but is in the area of financial calculating, what is called the double entry accounting method, very common. And this can also be done. So we have two perspectives. We're coming down, which risk might appear, and then we're looking upward, what we find, and can compare, does it match or not? It's a further way to check consistency of our data. So here I can show it's a usual V model with a little bit option of agile development, and at each of the gates, based on the data structure we find, we can create logical questions as the auditor that we say, okay, does this happen? If it is a mitigation, is there a test regarding effectiveness? Is this a primary operating function? Do we have a usability testing? And this is always covering a lot of questions you will face in an audit. So you can automate this. So this is something what you not have to do manually. So this is more or less a sequence of questions what you can automatically work out and run for each audit, so that an audit, you will always start in a logical order, and your audit reveals your mistakes, and you work it down from top to bottom until all fields are green. And then you have a very consistent data set in regards of data logic. And if we are doing this, then the question here is, I would agree that it is a very much workload. So touching every requirement, asking for every requirement, these questions. I agree, but the next logical step now, what has to come is that if we have our requirement item with all these attributes, this requirement item is not the only one what we have in our database. So if we go here in, we have a lot of data objects with a lot of attributes what we can manage, or better, the machine will manage it for us. So that means we have additional information like what are the core functions, what is the intended use of the device. Each requirement will have module interfaces. It will have a module architecture with information. What are the modules good for? We will have our intended user. We will have the profile of the intended user, the qualification profile of the intended user. So we have quite a lot of information we are sitting at if we have all this information in a database. So that means in the next step, we can now use AI to ask this question. Is there a risk if a requirement will be fulfilled, or is there a risk if a requirement will not be fulfilled? And all this information can then be streamed into the hazard, the sequence of event, the hazardous situation, harm, affected parties, and even mitigations. So if we have the whole architecture in, if we have technology redundancy in, then we can show that this all is possible. coming to summary, the takeaways for this tiny introduction here. So I think the audit experience was really a wake-up call for what we have done in the past. So that shows that the weakness in data logic, so what also my previous speaker already mentioned, are major risks for critical findings in audit. And I think it's very easy to overcome these risks with a good data logic, with logical networks in our database. Database assisted design, I think it's more or less nowadays a must-have. So this is based on the complexity of the products, based on the complexity of the requirements a manufacturer has to fulfill to get the compliance for this product. You need to support, you need to help, you got help by a machine to get this information crunched and brought in a system and in an order. And therefore, it is very, very important to use much as possible attributes for this handling here. And if you have done this, then it is very easy to go from random sample testing to a full coverage testing of your device, not only in regards of risk. Whatever happens, so what an auditor can prove with an auditor logic without having deeper knowledge of your device, a machine can always check. Risk coverage is mandatory. That is not an option. And the more you have this deep understanding, you can use this integral and comprehensively. And as I showed, it is also, you have in your data architecture, you have the architecture of your product already. So, and if you go down on this architecture with your risk assessment, you are making more or less this kind of failure analysis based on a product tree. So there is a smart combination of both methods in this here. Change management is a success factor. I think a fast change management, a robust change management is a must-have to get rid of surprises in the marketplace. So this is something you should consider in the future. The next point is dashboard supported transparency. So, I mean, if you have all these parameters in your data sets, you can have dashboards. So that means all project managers and so on will see this information already. This is not a surprise on a gate to review. This is something where you can straightforward work during your development. And the next logical step, I think the more AI has capabilities, AI can be incorporated into this kind of structure. So this is a mixture of data queries and AI analysis. So it's not that you are just putting some disconnected information. So an AI would not give you a good risk if you are just throw in a single requirement. What happens if the button fails? Yeah, because the AI does not know what the button is for, what kind of button it is, what options of failures might be. These are all information. They only come from this kind of data structure.